Hello students, Ms. Slyman here. In this lesson we're going to look at candidates test, which is a way of determining extrema and our values of global extrema specifically. So remember in the last video we talked about critical points. Critical points are where derivatives are equal to 0 or undefined. So we want s prime of t to be equal to 0. Or s prime of t does not exist, but my s of t is a cubic function. I know that that's always going to be differentiable, so this part is not applicable. So let's look at s prime of t being equal to 0. I'm going to take this derivative. My 0.2 is a constant, I can leave that in front, and then bring down my 3. Using power rule, I'll get 2x squared minus 41x plus 90 equals 0. Since it's equal to 0, I can divide that 0.2 to the other side. I could also factor out a 2, but that's going to give me back my 20.5, and it's easy to factor in this form. So I'll have 2x, x, and then minus 18, that's going to be negative 36, minus 5. I get my 90, I get my 41. So now x is either 5 over 2 or 18. I want to know my critical points, so I also want to know the y values at those points. And I used the variable x when I should have been using t. 2t squared t, 2t, t. Okay, so I can find my s of t values using my calculator. Of course, in this case, that means I also could have differentiated with my calculator. So let's go ahead and figure out our, I did not want to do that. Let's add a calculator page. And it's easier to add let's try it again, add a graph page. And I like adding the graph page because it's easier to work with the f of x if it's coming from your graph. So our function was 0.2, and then we had 2/3. So I am going to use x on my calculator because I've got f1 of x minus 20.5 x squared plus 90x plus 1150. All right, so I've got some function here. I'm not actually going to look at it because I don't mind so much. But I am going to do f1 of 5 over 2. And I'm also going to calculate f1 of 18. And just to show you how we could have found our derivative this way, menu, calculus, derivative. So I'm going to take the derivative with respect to x of f1 of x. And here's my derivative. They did factor out that 2. Like I said, we could have done that. Or we have our version, which had the 0.2 x squared, 0.2 times 2t squared minus 41t. That was plus 90 there. All right, so now we know our s of t values as well. So s of 5 over 2 was the 251.46. Our s of 18 was 3.2. And I'm going to go 2-0 because it's values of stocks, so we're thinking money. So 2 decimal places for our money. At which value does a stock have a relative maximum? So relative maximum here, that's the same as saying a local max. And in this scenario, a relative max is coming from a turning point. So our relative maxes, we're going to use we're going to look at the critical points. So looking at our critical points, I'm going to go ahead and take those critical points and put them on a number line. So we had 2.5 as our first t value, 18 as our second. If we look at the left of 2.5, that's like 0, for example. If I plug 0 in, I'm going to get negative times negative, which is positive. So I'm plugging these into the s prime of t values. We know it was 0 here. It's positive on this side. Picking a number in between these two, so I'm going to pick something like 10. Then I'll get positive times negative, so that's going to be negative. I know at 18 it was 0. A number bigger than 18, like 20, positive times positive is positive. So thinking about my derivative, the slope went from positive, so increasing, to 0 to negative. That means I have a relative max at t equals 5/2 because s of t went from increasing to decreasing at 2.5. The stock value at that instant, that was my $251.46. The relative minimum is at t equals 18, since the s of t function went from decreasing to increasing. So my derivative went from negative to positive at that point. We know that our value is $3.20. Now I want absolute highest value. So now I need to do what we call the candidates test so that I'm comparing my critical points to my endpoints. So I'm going to use the candidates test. Candidates test to compare endpoints to critical points. So we know that highest value, I want to look for maximums. So I'm going to look only at my 2.5 and the 251.46. So I'm going to compare. So now we're looking at t equals 0, t equals 5/2, t equals 18. At 0, we get 0.2 of plugging into my original. I'm going to get 0.2 times 1150, but I've already put it in my calculator. So I'm going to do f1 of 0. I'm also going to do f1 of 28 while I'm there. So those are my two endpoints, 230 and 446.53. So here I said 18, that's not the endpoint. That was one of my minimums, so I don't want to look at that if I'm looking for a maximum. I want to look at the last day of February. So I compare my S of 0 value, which was 230. S of 5 halves was 251. So putting them in order, we had this one was less than this one was less than our 446.53. Goodness gracious. Oh, yeah. Come on. There we go. 446.53. So our last point here, our end point, the last day in February, gives us the absolute maximum value. Repeating this again, my absolute lowest, I'm going to do my candidates test, and you need to refer to the candidates test. So I'm going to do candidates test with 0, 18, and 28. So 18 because I know that was a local min. And I will find that 18 is also my global min. So putting this together, if I'm going to toolkit candidates test, I'm going to use candidates test to find absolute extrema. All right, why are you? There we go. I'm going to use this to find absolute extrema. I'm going to list all my critical points and my endpoints. I'm going to compare the values of the function, not the derivative. So you want to look at the function. And then you're going to write your conclusion, and you're going to say that you used the candidates test to do that. So I'm going to stop you here. I would like you to go ahead and continue, do your CYUs, toolkit your candidates test, and remember you can always refer to that answer document to go back and check your answers.